Hey there, welcome to the video. And if you're new to the channel, on this channel I share what I learn on my journey related to tech, life and just things I find fascinating. So if you like this video, do subscribe to the channel, share it in your socials, tag me on Twitter. That would mean a lot to me. And without further ado, let's just get into the video. So after watching this video, you'll have a great idea about what TypeScript is, how the code looks, how it works, and why it is being preferred over plain JavaScript, and what is the difference between both of them. So let's just get started. So I have always been using JavaScript with React to make my own projects and things like that. But recently, where I started working as an intern, they specifically told that we use TypeScript, and obviously I didn't know what TypeScript was. I had obviously listened a lot about it and made some random Google searches, where if you do, you get that TypeScript is a superscript of JavaScript and it is strongly typed, which made totally no sense to me, and I didn't even care to go deep into it because I did not require it, right? But now I did, so I just started exploring how things work and things like that. So that's why I'm confident to make this video now. So first, let's understand what does this line mean, that is TypeScript is a superscript of JavaScript. So what this means is JavaScript is something which is being wrapped around with TypeScript, right? So it means that if you have a JavaScript file and you just change the extension to TypeScript, that is .ts, so instead of .js you just do .ts, it will work perfectly fine, right? But that doesn't mean okay, so before we get into the technicalities of how things work, let me first tell you why TypeScript was developed at the first place and what problem did JavaScript had. So the JavaScript team introduced JavaScript as a client-side programming language, right? But as time passed, developers started also using it in the server-side technology. So as the code base of JavaScript started growing and it became really big, it became really complex and hard to find things, had to find errors and things like that. So that happened mainly because JavaScript is not an object-oriented programming language, so we can't implement classes, inheritance, things like that to make things cleaner in the code base, and also because it is a dynamically typed language and not a static type language, right? So you must be wondering, well, what are static type and dynamical type language? Well, don't worry, I've got you covered. Okay, so in dynamic type languages, for example in JavaScript, in Python, it does not care about what type you use for a variable. For example, in JavaScript you can declare anything in a let, in a variable or things like that. It does not care about what's in it. For example, if you just in JavaScript or Python you do something like a is equal to a string, and then you do a is equal to a number, and it does not care. And that's why when your code base grows, you will just not find bugs. It will show you that okay, everything works fine. For example, if you have a function which takes in a number, right, and then in your code base grew, and then what someone did was he or she just put in some string as a parameter, and when that happens you will not get an error, right? So that's why TypeScript had to come in as a static type language. For example, things like C++, Java, these are all static type language. You will get an error in the compiler when you pass a number into a variable which was actually declared as a string. For example, if your string a is equal to abc and integer b is equal to 10, can't do this. We can't do b is equal to an string and just not get an error in static type languages. For example, C++, Java, TypeScript, right? So that's why TypeScript is used to just make things clean, to get these errors while you are compiling. That's why it is used, and that's how it is. It just dominates JavaScript, right? It just fixes all those things that are not good in JavaScript, and also it has oops concepts like class and inheritance, so that makes things really clean, right? Yeah, so now you know what is a static type language and what is a dynamic type language. So to remove all these things, TypeScript was developed and is now maintained by Microsoft. So TypeScript introduces all those oops requirements that JavaScript did not have, and also it is strongly typed, so that solves it all. So now that you know why TypeScript was invented, what problem it solves, now let me tell you how it works and how it makes life easier for developers and things like that. Okay, so TypeScript, so the browsers can understand a thing in TypeScript, right? They can only understand JavaScript. So that's why when you compile something that you write in TypeScript, it eventually gets compiled into JavaScript and gets stored, which is eventually read by the browser and is understood, right? So TypeScript makes things really easy for developers to find errors and bugs, things like that, while it is also working for the browsers as it gets transpiled into JavaScript. So the compiling of TypeScript into JavaScript is called transpiling, right? So that's how TypeScript works on the browser. So you know what, let me show you some code of how TypeScript works and how it gets transpiled into JavaScript, or how it looks in JavaScript after the TypeScript code gets transpiled into it. Okay, so let me just first show you a normal function, okay, in JavaScript. Okay, so yeah, this is how a normal function looks in JavaScript, but the similar function, if I just write in TypeScript, so you'll see, so now it gives an error, right? So if you just hover over it, you will see that it says parameter A implicitly has any type. So any here, so this is how you actually give a type in TypeScript. So you just use this colon and yeah, just give it any type, for example string. Now that means that A is now a string, right? A is now a string, so it tells us that if we don't give it anything, it is implicitly any of any type, right? So it could be anything like string, a number, things like that. So when we have any as a type, we can just pass in anything like a number, a string, a boolean, and it will not give us any error, and it will just accept anything like JavaScript does, right? For example, so if I just pass this A into some other variable, so let be a number, right? A number, we will pass an A into it, you will see there will be no errors. And if I even just do it a string, now also we will have no errors. So that means that, so if we just give a character any, that means that it does not care about what type it is getting, it will just use it. That is how JavaScript works. So to solve that, we have these types. So if I just give it string here, or if I just do it number here, okay, number, that means A is a number, we are accepting the parameter as a number type. Now you will see B will have a red line under it. If we hover over it, you will see the error that type number is not accessible to type string. So as you can see, B is a string type variable and we are passing in a number into it. So that is how TypeScript works, and it just senses things when we compile, and it gives us error so that we don't have to again just scratch our heads where we are getting error. That would have happened if we had a larger code base and we just had passed a number into a string variable in JavaScript, and it will just happily take in, right? So now if you just say this is how a TypeScript code looks, but it gets transpiled into JavaScript, and this is how it looks in JavaScript, right? So yeah, that's how it works. So let me just correct it. So to correct it, I will just do a number. So yeah, now B is a number and A is a number, and everyone is happy. Our types are working. Well, we will be very happy as developers, I guess. Okay, so these are some differences that you may want to know to just get things more cleared out. Okay, so as we discussed, TypeScript is a superset of JavaScript developed to overcome code complexity for large projects. JavaScript, a scripting language that helps create dynamic web page content. Error can be found and corrected during compile time, which is a huge relief for developers, software engineers. And JavaScript errors can be found only during runtime. You will just see the error in the consoles or things like that when you run, not when you are compiling in your editor or things like that, right? So that is a really awesome thing. So these 2 points are like the main thing why TypeScript was invented in the first place, right? And yeah, it is strongly typed, which we now know what is strongly typed. It means probably just static typed, and yeah, supports both static and dynamic type. It supports both, but this is just weakly typed and just supports dynamic typing. And yeah, converted into JavaScript code to be understandable for browsers, which is actually called transpilation, or being transpiled from TypeScript to JavaScript. And this is just can be directly used by browsers because browsers just understand JavaScript, right? Now, since it is a superset of all the JavaScript libraries and other JavaScript code works without any changes, and JavaScript libraries work by default. So it just says that every JavaScript library that you just used, it also does work in TypeScript, right? So that's all. And it also has support for all these JavaScript versions, and yeah, you can just compile the TypeScript you write into any version of JavaScript you want. So that's what it means by this point. So this line just means that TypeScript is object oriented programming language, and it supports things that we have learned in classes, things that we have learned while using C++ or Java, like interfaces, class, extending, implementing things, right? So these could not be done with JavaScript, so that made the code really messy, but TypeScript solves all of it, and it just maintains a really scalable and clean code, right? So that's what this line means. And yeah, so but here we have no support for this object oriented things, right? So yeah, that's all about the differences. Now let's move on. Well, now you must be wondering, well, do I need to use TypeScript? Well, JavaScript really works for me. So yeah, you are totally right. JavaScript is great for small size projects or even medium size project that we make at our home, or things like that. But when you go to enterprise level softwares, for example, when you use full stack, when you do full stack development where the whole server side is also JavaScript, well, the whole front end is also JavaScript, and there is a just big code base. I mean, TypeScript solves a lot of things, because you get IntelliSense when you use JavaScript, when you use TypeScript, because you are using classes, inheritance. So when you import those things, you just get great suggestions while you're just coding. You get your errors get showed up when you compile things, because it is that's why TypeScript was made, to just catch errors and find bugs easily for developers, right? So that makes life really easy, but that's only when you have a really large code base and things like that. But if you are just working out of your home and spinning small projects, JavaScript is pretty clean and good for it, right? So that was the video. I hope you learned something, and if you did, just let me know in the comment section below. And yeah, if you like this video, do subscribe, give it a like, and you can always hit me up on Twitter or LinkedIn. So yeah, I'll see you in the next video. Have a great day.